Hello everyone, my name is Radu Horoiu. I'm a professional services engineer at Infinet Wireless. Thank you very much for joining our webinar. Today we are going to discuss about the main benefits of replacing the WiMAX 16D and 16E systems with the Infinet Wireless solutions. The agenda for today includes 4 items. I will start with a short overview of the WiMAX technology, pointing out its main characteristics. Then I will briefly review the proprietary broadband wireless systems, highlighting the main differences in comparison with WiMAX. In the third item, I will explain why the Infinet Wireless systems are a good option for the WiMAX equipment replacement. I will point out the main WiMAX shortcomings. Then I will present the benefits that our customers get by choosing the Infinet solutions. And in the fourth and last item, I will show you a list of all the current Infinet products in the 3 GHz range, so you can become more familiar with our devices. Now, as you probably know, WiMAX stands for Worldwide Interoperability for Microwave Access, and it follows the regulations imposed by the 802.16 standard developed by the Institute of Electrical and Electronics Engineers, or IEEE. The purpose of WiMAX was to provide wireless last-mile connectivity as an alternative to the wired technologies like DSL or E1T1 links. WiMAX was specifically designed for point-to-multipoint topologies as a broadband wireless access application. The base station can be extended to a repeater station in a point-to-point topology, but without offering additional capacity. So it will just pass over the traffic collected by only one base station. WiMAX has been used as a last-mile connectivity solution mainly for small and medium-sized enterprises, high-end residential users, and mobile residential users. There have been 2 main types of WiMAX network deployments, WiMAX 16D and 16E. 16D is also known as fixed WiMAX because it had no support for mobility, while 16E is referred to as mobile WiMAX because it introduced mobility support. Now, the fixed WiMAX networks were deployed mainly between 2004 and 2008 in 3.4 to 3.6 GHz, both in TDD and FDD. Their network topology is very simple. These systems include just base stations, CPEs, and AAA servers if needed, so no other core network equipment was required. Because of the high CPE cost, WiMAX D was more suitable for business and high-end residential users rather than the mass market. Regarding maximum data rate, 16D base stations can deliver in theory up to 25 megabits per second per sector in 10 MHz. The WiMAX 16E networks were mainly deployed between 2007 and 2011 in 3.4 to 3.6 GHz, 2.3 GHz, and 2.5 to 2.7 GHz using TDD only. The network architecture of WiMAX 16E is more complex, including, besides the base stations and CPEs, core network equipment like ASN gateway for mobility, AAA server, and home agent. WiMAX 16E has been primarily aimed at residential users. The cost of the CPEs was significantly lower compared to 16D. Besides the mobility support, WiMAX 16E provides support for 2x2 MIMO on the downlink and also offers an improvement over the modulation schemes of WiMAX 16D. This means that the maximum data rate can reach up to 70 megabits per second per sector in 20 MHz. The IEEE.16 standard provides specifications for the physical and MAC layers, but it does not include any recommendation for the WiMAX network architecture. The WiMAX Forum, which is responsible for promoting the conformity and the interoperability of the standard, has developed a network model that represents the architecture framework for WiMAX deployments and facilitates the interconnection between WiMAX and other types of networks, including the Internet, PSTN, or packet-switched mobile networks. It also has the purpose of providing mobility support. The WiMAX 16E architecture, as I mentioned earlier, has a more complex hierarchical structure. compared to 16D, and it includes three main parts. The mobile stations, which are the devices used by the end user to access the network. These devices feature WiMAX extensions like external modems, WiMAX PC cards, or WiMAX USB dongles, or devices that have embedded WiMAX functionalities. The second part is the access service network, which includes the base stations and one or more ASN gateways. The ASN gateway typically acts as a layer 2 traffic aggregation point, and among other functions, it manages radio resources, mobility, and routing the traffic towards the connectivity service network. The third part of the architecture, called CSN, provides connectivity to the internet and to other public or corporate networks. The network service provider owns it, and it includes the AAA server and the home agent. The CSN is also responsible for QoS and security policies, IP address management, support for roaming, location management, and mobility. Moving on to the proprietary broadband wireless access solutions, I will point out the general characteristics and provide examples based on the Infinet Wireless systems. The proprietary broadband wireless access solutions are developed in a more specialized fashion with the purpose of creating high-end products for specific applications. The main purpose of proprietary BWA systems is to provide high-speed wireless connectivity over broad areas. Both point-to-point and point-to-multipoint topologies are available to offer flexibility for end-to-end connectivity. Proprietary BWA solutions address a wide range of applications like backhaul connectivity for ISP networks or wireless ISP networks for small cells and the enterprise segment. BWA also provides end-to-end connectivity for CCTV, supporting multiple HD streams. It also successfully addresses mobility projects like, for example, vessels in the ports or extraction fields, and to the energy and natural resources segment. The main difference between WiMAX and proprietary broadband wireless access systems is that the BWA solutions do not have a hierarchical network structure, so they do not require support from a core network. In this picture, we have a representation of a typical network architecture built using Infinet Wireless units. As you can see, both point-to-point and point-to-multipoint devices are used. The point-to-multipoint links serve the needs of the access part of the network, while the high-speed point-to-point connections address the capacity and the availability requirements of the aggregation backhaul segment. Moving on, I want to point out the main shortcomings of WiMAX that have determined the WiMAX operators to look for other solutions to upgrade their networks. First of all, the network capacity is too low for today's requirements. The demand for end-user data speed has increased more than 10 times since the deployment of the first WiMAX networks. So many of these deployments cannot keep up with the required speeds that reach 100 megabits per second or more. Also, since the current networks are already working at full capacity, there is no room for new subscribers, so the customer base cannot be increased. Next, WiMAX has poor MIMO support. Fixed WiMAX does not support MIMO at all, and mobile WiMAX only implements MIMO on the downlink. So this is also one of the reasons why the capacity is low. Another important drawback of WiMAX is the relatively high delay, which is typically around 50 milliseconds. This means low performance for latency-sensitive applications like VoIP or live video streaming. Next, WiMAX 16E only supports asymmetrical traffic. The uplink to downlink ratio is about 1 to 3, and it is fixed, so this means poor support for uplink-focused applications like video surveillance or apps that store a lot of data in the cloud. WiMAX 16D offers symmetrical throughput, but the data rate is much lower. In the recent years, WiMAX has gradually become obsolete. There is no roadmap for new WiMAX developments or upgrades, and most WiMAX vendors have either disappeared from the market or have shifted their focus towards other technologies, like TD-LTE, for example. As a result, many WiMAX operators have no choice but to look for other technologies as well. Moving on, I want to highlight a few of the reasons why the Infinet Wireless devices are a good option when it comes to replacing the WiMAX equipment. The first reason is that the Infinet devices can operate using the same 3 GHz frequencies and channel bandwidths as the WiMAX equipment. So we can cover the whole 3 GHz spectrum from 3.1 to 4 GHz and also support the usual WiMAX channel bandwidths 5, 7, 10, 14, 20 MHz and more. The second reason is that we offer the possibility to implement SLAs for each customer. The Infinet R5000 series allow you to fully configure the committed information rate and the maximum information rate using the QoS configuration menu. Next, we provide radius support so that the existing AAA servers can be used for CPE authorization. We also offer the possibility to sync the TDMA transmission and reception with the existing WiMAX equipment. By using the 5 millisecond frame size and GPS synchronization, Infinet units can operate alongside WiMAX devices so that the migration can be done gradually. And last but not least, Infinet systems provide support for mobility. The unique advantages of the proprietary Mint protocol and the possibility to configure multiple base station profiles on the CPEs allowed the Infinet Wireless units to be used in various nomadic and mobile scenarios. There are 3 possible Mint operation modes: fixed, nomadic and mobile. The difference between these operation modes consists in the time interval at which the Mint information exchange takes place between the nodes. This interval varies between 3 seconds in fixed mode to 1.5 seconds in nomadic and only 1 second in the mobile mode. A few of the mobile scenarios where Infinet units can be used are railways, vessels in ports, and construction or mining sites. In the next section, I want to show you some of the additional benefits that you get by choosing the Infinet Wireless systems for the WiMAX equipment replacement. So the first major benefit is the much higher sector capacity of up to 240 megabits per second in a bandwidth of 40 megahertz. Then the signal processing is much faster and the delay is predictable and low, typically less than 5 milliseconds. The Infinet units offer support for both symmetrical and asymmetrical throughput. The downlink to uplink ratio is configurable between 20% and 80%, or it can be set automatically by the equipment according to the traffic load distribution. This mode is called dynamic TDD. Our products are specifically designed for direct connectivity and integration with the IP networks by implementing a comprehensive set of networking protocols and features, so there is no need for gateways or other core network devices that are necessary for WiMAX 16E networks. Of course, because there is less required equipment, the acquisition costs of Infinet Wireless systems are much lower compared to WiMAX or other technologies like TD-LTE. Our CPEs can be purchased with license upgradable throughput of 8, 20, 50 or 180 megabits per second. This way you can optimize your capex by only paying for the performance that you need for each CPE. The next important benefit is the frequency channel reuse within a cell. The TDMA software coupled with GPS synchronization using the external GPS hub enable a frequency reuse of 2 within the same site. Our GPS synchronization hub can provide positioning and precise timing reference for up to 7 InfiMAN 2x2 base station sectors or InfiLink 2x2 Pro units. It has an embedded GPS receiver and an active antenna. Thanks to the GNSS-based time reference, it enables intra-site and inter-site synchronization. And it also provides geopositioning information and UTC. The frequency reuse of 2 means that with the Infinet Wireless devices you can create a 4-sector cell using only 2 frequency channels by assigning 1 channel to 2 back-to-back sectors. As a result, you can get much more capacity using less spectrum. For example, if you use two 20 MHz channels, you can achieve up to 480 megabits per second and a spectral efficiency of 12 megabits per second per hertz. With WiMAX, the total capacity you can get within a 4-sector cell is about 280 megabits per second, and to achieve it you have to use 4 20 MHz channels, so twice the spectrum required in the Infinet Wireless setup. The spectral efficiency is much lower at about 3.5 megabits per second per hertz. Moving on with the next benefit, as I have mentioned earlier, the architecture of the Infinet Wireless networks is less complex than the architecture of the WiMAX networks, mostly because there is no need for core network support. Next, Infinet Wireless provides an end-to-end connectivity solution supporting both point-to-point and point-to-multipoint topologies, in contrast with the WiMAX or LTE solutions, which are oriented towards last-mile connectivity using only point-to-multipoint topologies. We also offer products in other frequency bands like the 5 GHz unlicensed spectrum or 6 GHz, thus increasing the flexibility of our solutions even further. Infinet Wireless provides a full-featured NMS solution called InfiMonitor, which I have presented during our previous webinar. InfiMonitor offers useful features like real-time status monitoring of all Infinet devices, network map, events, statistics, and many others. If you haven't been able to join our previous webinar, you can find the recording on our YouTube channel. The next benefit is the long range that you can achieve using Infinet devices. Point-to-multipoint links can be established at distances in excess of 30 kilometers, and point-to-point links can operate beyond the 100 kilometers using external high-gain antennas. Also, our products can work in both line of sight and near or non-line of sight scenarios. All Infinet units can be ordered either with integrated or external antennas. So not only the CPEs but also the base stations can be fitted with higher gain antennas than the standard ones. The Infinet wireless units are reliable and robust. Their configuration and maintenance can easily be performed by a small number of technicians. Each unit features a built-in surge protector and an IP66, IP67 compliant aluminum enclosure. The mean time between failures is 150,000 hours for all models. Compared to the WiMAX devices, all our units are more compact and also lighter, especially the base stations, so they occupy less tower space. The power consumption of the Infinet units is much lower compared to WiMAX, up to 12 watts for a base station and up to 7 watts for a CPE. And of course this leads to a decrease in the overall operating expenses. Besides standard protocols, our devices feature proprietary extensions to standard protocols and new proprietary technologies to best accommodate the application requirements. So for the management of the devices, you can use HTTP, HTTPS, SSH, SNMPv3 and console. We offer a wide range of utilities and services like ping traceroute, ACLs, over-the-air software upgrade, spectrum analyzer, antenna alignment tool, traffic statistics, and many others. The Infinet devices have full layer 2 switching capabilities, so we have support for VLANs, QNQ, STP, IGMP, and so on. Our units can operate as routers using static routing, OSPF, RIP, or Mint routing. Packet filtering can be done up to layer 4. We support NAT, IP firewall, DHCP server and client, tunneling, IP forwarding, and many others. The proprietary Mint set of protocols operates between layers 2 and 3 of the TCP/IP stack. Each Mint unit or node has the full Mint map of the network containing the Mint neighbors and the routes to all Mint destinations. The network path is calculated for every frame or packet, and it is selected according to the lowest overall cost, which is calculated by taking into account parameters like SNR, RSSI, bitrate, percentage of retries, and the link load. Another important benefit of the Infinet wireless systems is that we can implement two different medium access methods, TDMA or polling, as opposed to WiMAX and also LTE, which only use OFDMA. Polling mode is a dynamic marker access method in which the master unit or the base station is responsible for allowing all the slave units or CPEs to transmit their data in turns for different periods of time according to the amount or type of traffic that each unit has to transmit. Both the TDMA and polling methods are based on allocating all the physical resources or subcarriers to each unit for a certain amount of time. So compared to OFDMA, which is used by WiMAX, TDMA and polling require less overhead and fewer guard intervals, thus allowing the achievement of an overall higher capacity. With TDMA, the maximum number of recommended CPEs in a sector is 32 in 20 MHz bandwidth, while with polling there is no actual limitation. The last major benefit I want to talk about is the advanced QoS features that the Infinet units have. So our products feature enhanced proprietary QoS mechanisms which are close to the Ethernet QoS techniques. And the main difference between WiMAX and Infinet with regard to QoS is that WiMAX uses a connection-oriented approach. So for each subscriber unit, more connections can be established to support different traffic types. This method implies having an increased and more complex signaling procedure. The Infinet QoS, on the other hand, can be configured with no prior connectivity between the CPEs and the base station. Automatic QoS is enabled by default on our units for 802.1p for all RTP traffic and ICMP, but if you want, you can change the default settings. The Infinet R5000 units feature 17 mint priorities that can be assigned to different types of traffic. WiMAX only has 5 predefined priority levels. Additionally, we have 200 logical channels or logical queues that can be used as a buffer before the physical queues. The Infinet units natively recognize the standard prioritized traffic, .1p, TOS, DSCP, and so on, and the priorities are fully customizable, so you have full freedom to change the priority of each data stream. And classes can be used to define bandwidth allocation policies and ensure the bandwidth requirements for each service type or customer. This way, you can configure the committed information rate and the maximum information rate. Now, because TD-LTE system vendors are also approaching WiMAX operators that need to replace their existing WiMAX infrastructure, I want to highlight some of the advantages of the Infinet systems over the TD-LTE systems. First of all, the costs and the network complexity are lower, mostly because TD-LTE requires core network equipment. Then the maximum network capacity is higher at 240 megabits per second per sector versus 200 megabits per second per sector with LTE. The QoS capabilities of Infinet units are more advanced. The uplink and downlink bandwidths can be dynamically allocated. Infinet provides more advanced layer 2 and layer 3 networking functionalities built in the same software platform running on both the base station and the CPE without the need of external network devices. TD-LTE systems use an EPC gateway for providing core functionalities, so they don't offer layer 2 transparency. And of course, the power consumption of the Infinet units is much lower at maximum 12 watts for a base station versus 100 watts for an LTE eNode B. We have arrived to the last part of today's presentation where I will show you the list of the Infinet wireless products in the 3 GHz range, just so you can become more familiar with our products. And I will start with the point-to-multipoint solutions, which are called InfiMAN 2x2. First, we have the base stations. There are two main models, both with 23 dBm maximum output power and 240 megabits per second maximum capacity in 40 megahertz. The first model has the 14 dBi 90 degrees dual polarization integrated antenna and the recommended maximum range of about 20 kilometers, while the second one has two N-type connectors for an external antenna which can extend the range to about 25 or 30 kilometers depending on the beam width of the antenna that you want to use. Both models can be ordered with one of the four operating frequency ranges: 3.4 to 3.7 GHz, 3.1 to 3.4 GHz, 3.7 to 3.9, or 3.9 to 4 GHz. Next, we have the subscriber terminals. There are three main models this time. The maximum output power is the same as for the base stations, 23 dBm for all of them. The capacity is license upgradable, so you can choose between 520, 50, or the maximum of 180 megabits per second. The first two models have integrated antennas with 19 dBi and 22 dBi, recommended for distances of up to 10 kilometers and 12 kilometers respectively. And the third model comes with two N-type connectors for an external antenna, which can extend its range up to 25 or 30 kilometers. The four frequency ranges are the same as for the base stations. Moving on to the point-to-point solutions, which are called InfiLink 2x2, and first we have the InfiLink 2x2 Lite devices, which from the hardware point of view are identical to the subscriber units. The only difference is that the InfiLink devices can be configured as masters, while the subscriber units are slaves only, and of course their range is greater, since we are talking about point-to-point links where both units have high gain narrow beam antennas. So the first unit with a 19 dBi integrated antenna is recommended up to 15 kilometers. The second unit with 22 dBi is recommended up to 25 kilometers. And with the third unit, which can be fitted with an external antenna, the link range can exceed 75 kilometers. Next, we have the InfiLink 2x2 Pro devices, which have the same RF output power as the Lite units, but much more data processing power, which enables them to provide a capacity of up to 280 megabits per second. The antennas are the same: 19 dBi recommended up to 20 kilometers, 22 dBi recommended up to 25 kilometers, and the external antenna for distances of up to 80 plus kilometers. And finally, we have the InfiLink XG, which is our flagship product. It uses a single carrier modulation technique as opposed to the rest of the products, which use OFDM. It has a maximum output power of 27 dBm and a capacity of up to 500 megabits per second in 40 megahertz, which makes it a very good choice for backhaul applications. One single XG unit covers the whole 3 GHz spectrum from 3.1 to 4 GHz, and it can be ordered with either an integrated 22 dBi antenna for distances of up to 30 kilometers or with N-type connectors for an external higher gain antenna, which can enable long distance links of up to 100 plus kilometers. So this completes our agenda for today. Thank you once again for your time, and hope to see you again during our next webinar.